Hello, this is Mr. Henry, and this is lesson 3.1. Today we're going to be solving one-step equations, and the essential question is, how do I solve one-step equations? Okay, we have our four get the goofs here, so let's see what we should do. Let's see, well, just thinking about it, what number plus 4 would equal 15? If I plugged in 11 in for h, is 11 plus 4 15? Yeah. So this guy is actually correct. Now we did that using mental math, but that's actually a correct answer. Okay, let's check number 2. If we plugged in 2 here, is 2 minus 6 equal to 8? Well, 2 minus 6 does not equal 8, so we know that this is a wrong answer. So then you think, what number minus 6 equals 8? And the number we should come up with is 14. 14 minus 6 equals 8. Okay. Number 3, 4 times what number is 20? Now this is multiply. Whenever you see a number multiplied by a variable, or right next to a variable like this, it is multiply. So 4 times what is 20? Well, 4 times 6? 4 times 6 is 24. 4 times 5 is 20. And number 4, what number divided by 4 is equal to 2? This looks like a fraction, but all a fraction is division. So this literally means what number divided by 4. So if we plugged in 2 here, is 2 divided by 4 equal to 8? No, that doesn't work out. So the number divided by 4 that equals 8 is actually going to be 32. Now if you couldn't do those in your head, lucky for you, we're going to have a method today of solving these types of problems without doing the work in our head. We're going to actually have a method to do it that's going to make our lives a bit easier. Okay? We have ourselves 3 vocabulary words. The first word is inverse operations, then we've got equivalent equations and reciprocal. Inverse operations are 2 operations that undo each other. Okay? Two operations that undo. Ooh, that's not an N. Undo each other. Now, those are things like add and subtract. Those two are opposites. And adding and subtracting cancel each other out. Or multiply and divide. Those two things cancel each other out. Okay? Equivalent equations are 2 equations that have the same solution. Two equations with the same solution. And you could think of something like 2x equals 8. You can guess the x right there would be 4 because 2 times 4 is 8. Or if I said 4x equals 16. Those two equations are equivalent because they both have the same solution where x would equal 4. Okay? And the last vocab word is reciprocal. Now this is a throwback from back in the day when we did fractions. Think about when you're doing multiplying and dividing fractions. One of the words that came up was a reciprocal. And the reciprocal of a fraction is when you take a fraction and you flip it upside down. So I'm going to call this thing the upside down, in quotes, the upside down version of the fraction. So you can think of it like 3/5. The reciprocal would be 5/3. How you just take it and you put the numerator in the denominator, denominator in the numerator. A couple things that would be similar to this, or a couple other examples. If you have, say, a whole number, 3, and you need to write the reciprocal of that, well, this 3, if we would write this thing as a fraction, would be 3/1. So then when you flip the top and the bottom, the numerator and denominator, you'd get 1/3. That's the reciprocal of the whole number 3. And it's not going to come up today, but just for your reference, if you have something like a mixed number, 2 1/5, the first thing you would do is you'd take the 2 1/5, turn it into a fraction. So 5 times 2 is 10, plus 1 is 11/5. Now you have a fraction. Then you flip it, you get 5/11. That would be the reciprocal of 2 1/5. Alright, so we got reciprocal, we got all our vocab. Now let's actually see some of these problems being done. So here we have our 4 questions. We're going to solve these one-step equations. Now, in each of these questions, you're going to need to show your work. Do not do this using mental math. It might work for these questions, but when we get to the next couple sections and we're doing 3, 4, 5-step equations, you're not going to want to do those steps all in your head. You're going to make big mistakes, and that's not what we want. So, show this work. So here's how this works. You're going to, first off, you're going to find the variable. There is my variable. You want to underline it, go for it. Or put a box around it, go for it. I don't care. That is the variable. You have to find it. Now, what math is happening to the variable? Well, this is a nothing. That's not math. That's not add, subtract, multiply, divide. That's nothing. So my variable is being added by 8, or it has this 8 being added to it. The way you're going to solve an equation is you always do the opposite of what's happening to the variable. So the opposite of adding 8 is to subtract 8. Now let's see what happens. When we subtract 8 here, 8 minus 8 is 0. On this side, when we minus 8, 5 minus 8 is a negative 3. That is the correct answer. If we would double check our work, if we plug this y, this negative 3, back in for the y, so I'm going to write the problem again, equals 5. If we plug in negative 3 here, so 8 plus a negative 3, does that equal 5? Well, 8 plus negative 3 does equal 5. That is our answer. Y equals negative 3. Okay, letter B. First off, find your variable. There he is, right there. What math is happening to that? This variable is being multiplied by 12. So then you think, okay, what's the opposite of multiply by 12? Well, divide by 12. Divide by 12. When you do that, this multiply and this divide cancel because they're opposites. That's the whole point of dividing by 12. So we get m equals on this side because these guys are gone. On this side, when we divide by 12, well, just 36 divided by 12 is 3. And if we really wanted to, we could double check our work. 12 times, plug it in. We said m is 3. Does that equal 36? And the answer is yepers, because 12 times 3 is 36. Oopsie. It works. Okay. Letters C and D. There is my variable. The variable is being subtracted by 8. This is not a math. This is just an equal sign. It's basically separating two sides of the problem. Okay? The variable is being subtracted by 8. So the opposite of minus 8 is plus 8. Now look what happens if we actually do this math. A minus 8 and a plus 8 are opposites. They cancel. That equals 0. So on this side of the problem, we're left with just the p. But when we add 8 to this other side of the problem, 5 plus 8 is 13. Letter D. My variable, there he is, sitting up top there. The variable is being divided by 4. Well, the opposite of dividing by 4 is to multiply both sides by 4. When you multiply this side by 4, a times by 4 and a divide by 4 are opposites, so they cancel out. They're gone. A equals. On this side of the problem, a negative 16 times by 4 gives you a negative 64. Okay. And we could always double check if we wanted to, but you can trust me if you want. Negative 64 divided by 4 does equal a negative 16. Check it on your calculator. Believe it or not, it is true. So, the moral of the story is, first off, you find the variable. Second thing you do, you always do the opposite of what's happening to the variable. That's the slogan you're going to hear me say a bazillion times from now until the end of the chapter or until you're done with algebra. In fact, anytime you're solving an equation, that's what you do. Okay? So, you've seen 4. Let's give a couple for you to try on your own. Take a couple minutes, pause the video, try these problems out. When you're ready, hit play, and we'll continue on. Alright, hopefully you had time and you tried these problems on your own. Let's see how they do. There's my variable. My variable is being added by 3, so I subtract 3 there and minus 3 there. A plus 3 and a minus 3 equals 0. On this side, a negative 3 minus 3 is a negative 6, and I'm done. Letter F. My variable is being divided by negative 2. The opposite of dividing by negative 2 is to times by negative 2 on both sides. I don't think I mentioned that. You do always have to do everything on both sides. So here I'm timesing by negative 2 on one side of the equal sign, and you times by negative 2 on the other. Minus 3 on one side, minus 3 on the other. If I go back to the other page, minus by 8 on one side, minus by 8 on the other. Divide by 12, divide by 12. Plus 8, plus 8. You always do everything to both sides of the equal sign. Alright, so these canceled. We get r equals, and 5 times negative 2 is negative 10. Letter G. Well, we've got negative 3 plus w. So my w here, and this one's a little bit tricky. A lot of people think, oh, I have to subtract 3. Well, kind of. Think about it. What would you do to make this thing go to 0? The way you'd get rid of a minus 3 is if you plus 3. Because a negative 3 plus 3 equals 0. And plus 3 on the other side, w equals 6. Not 6. Let's erase that. 9 plus 3 is 12. And lastly, u minus 6. Okay, there's my variable. It's being subtracted by 6. The way I get rid of that minus 6 is by plus 6, 0. Plus 6, and u equals 6. Hopefully you had some success. If not, well, you've got 4 more problems coming up here to give a try. Make your best effort. Here we go. Oopsie, wrong page. How about that one? So try those 4 problems, copy them down, pause the video, try them out, and then when you're ready to continue, hit play, and we'll go over them together. Okay, let's see what we got. I'm going to go through these a little bit quicker because we should have a bit more experience by now. So we're going to variables being subtracted by 4, so I plus 4, plus 4. T equals these guys went to 0, so it's just a t equals, and a negative 3 plus 4 is positive 1. My variable is being multiplied by 7, so I divide by 7 on both sides. H equals 4. My variable is being divided by negative 7. The opposite of dividing by negative 7 is to multiply by negative 7 on both sides. These cancel, and g equals, let's see, Negative 14 minus 7. Well, that's going to give me a positive 70, and 28 is positive 98, I believe. Yep, I'm correct. Positive 98. Lastly, my variable q is being multiplied by a negative 2, so I divide by a negative 2. These cancel, and q equals a positive divided by 2 is 3. And that would be done. Okay? So, that's good practice. I'm going to have you do a few from the textbook. Again, practice doesn't hurt, so pause the video, try these out on the back of your note sheet, on a piece of scrap paper someplace, and then we will go through them here in just a couple seconds. Alright, let's see. I'm looking at the textbook, so I'm just reading the problems as we go through. So the first problem here says y looks like plus 7 equals 10. So you minus 7, y equals 3. Let's see, that's number 1. Number 2 says x minus 5 equals 3. So you add 5, x equals 3 plus 5 is 8. Number 3, q minus 11 equals a negative 5. So you plus 11, q equals negative 5 plus 11 is a positive 6. Number 4, 6 equals t minus 2. My variable is being subtracted by 2, so I add 2, these cancel, t equals 8. Let's see, how about number 5? Says 4x equals 48. Variable is being multiplied by 4, so I divide by 4 on both sides. X equals 12. Number 6. Negative 65 equals negative 5y. Ooh, click something. Y. Divide by negative 5, because the variable was being multiplied by negative 5, so I divide by negative 5. Y equals, gives me a positive 13. Those are the first 6. Pause the video if you need them. I'm going to erase them and do the next 6. Okay, and we're on number 7, I believe. It says 5w equals, oopsie, not 5w, 6w equals negative 54. The variable is being multiplied by 6, so I divide by 6, w equals negative 54 divided by 6 is a negative 9. Number 8 says 24 equals negative 8n. The variable is being multiplied by negative 8, so I divide by negative 8, n equals a negative 3. Number 9 is on page 136. And it says number 9 says t over negative 3 equals 9. The opposite of divide by negative 3 is a times by negative 3. T equals 9 times negative 3 is a negative 27. Number 10 says 6 equals c over 7. And we're going to Opposite divide by 7 is times by 7, times by 7. These cancel. C equals 42. Number 11. 13 equals z over negative 2. The opposite of divided by negative 2 is 2 times by negative 2 times by negative 2. These cancel. Z equals a negative 26 to 2. And lastly, number 12. Number 12 says a divided by 5 equals negative 11. Opposite of divide by negative 5 is the opposite of divide by 5, it's not negative, is 2 times by 5 times by 5. These cancel, and a equals negative 55. Alright, so that was all 1 through 12. Hopefully you had some good success. You're going to see the same pattern repeat over and over and over again. Now, let's start looking at example 2, where we start getting some fractions. Now, they look ugly, but what you're going to see is the process is pretty simple. It might be helpful if you have a calculator nearby that can do some fraction math, but it's really not that bad. So this problem says negative 2/7 times x equals 4. Now, the first thing you should think in your head is, okay, the variable is being multiplied by negative 2/7. So if I would divide, and by the way, don't write this down, but if I would divide by negative 2/7 on both sides, I should get my variable by itself and I'd get my answer. And that's absolutely correct. You would get your answer. And there's nothing wrong with doing it that way. If you have a calculator that can divide by fractions like that, do it. But there's a simpler way if you don't have a calculator that has fractions. The simpler way to do this math is by doing something we're going to call multiplying by the reciprocal. So what we're going to do is we're going to multiply both sides by the reciprocal. So we're going to take this fraction and multiply it by the upside down version, negative 7 over 2 times by negative 7 over 2. You go, why in the heck are we doing that? Well, first off, if you remember how to divide by fractions, the rule is to flip the second fraction and multiply. That's really what we're doing. When we said divide by that, we flipped it upside down and we multiply. Here's what happens. A 7 in the numerator and a 7 in the denominator cancel. 2 in the numerator, 2 in the denominator cancel. Basically, all of this stuff being multiplied by the x turns into just 1. And we can write just 1x as x. There's no need to write a 1 in front of it. We know there's one of them there. But on this other side, we turn the 4 into a fraction by putting it over 1, and we multiply straight across. Negative 28 over 2. And with a little bit of simplifying, we get the answer of negative 14. Yes, it's more complicated than what we were doing before, but it's not incredibly difficult. Okay? Letter B. My variable is being multiplied by this fraction. So we're going to multiply both sides by the reciprocal. This is the reciprocal of the fraction. Switch the numerator and the denominator. 5 over 1. Now look what happens. 5 in the numerator, 5 in the denominator, cancel. 1, 1, cancel. You're left with just the variable equals. On this side, 5 over 1 times 5 over 1 is 25 over 1. 25. Now if you put your 25 over 1 like this, that is just the same thing as 25. It really doesn't, you don't need that extra over 1 there. Okay. I'm going to leave A and B up there. I'd like you to try C and D right now, please. Pause the video, take some time. We'll go through them here in just a second. Okay. Letter C. So we're going to multiply both sides by the reciprocal of the fraction because the variable is being multiplied by this. So we multiply by 4/3. On this side, the 4's cancel, the 3's cancel, so all this stuff is gone. M equals. On this side, turn the whole number into a fraction, multiply straight across, and we've got negative 24 over 3. And if we simplify, we get a negative 8. M equals negative 8. Last one, letter D, is slightly harder, just because there's two fractions, but we're still going to, there's the variable being multiplied by the 1/3, so we're going to multiply by the reciprocal, the upside down version of that fraction. The 3's cancel, 1's cancel, this is all gone, we get y equals, and here when we multiply straight across, 1 times 3 is 3, 5 times 1 is 5, and that does not simplify. That is our answer. We can get fractions, we can get decimals, we can get all kinds of stuff when we are solving equations. Okay? Now the last type of problem we got to look at is just some applications, just some word problems showing what this is kind of like. When are some situations you might solve these types of equations in real world problems? So letter A here says, 3 days ago, a cow was milked and it gave 3.5 gallons of milk. Today, the cow gave 4.4 gallons of milk. What was the change in the amount of milk? Now, first thing I see, what was the change? Anytime you're trying to find change of something, you're almost always going to subtract. That's how you find change. Okay? So my hint is we're going to end up doing a subtraction to solve this problem. Let's think about this. 3 days ago, the cow gave 3.5 gallons of milk. Okay, so 3.5 gallons of milk. Today, it gave 4.4. We want to know how much was in between. Well, there's 3.5 gallons plus however much the change was now equals 4.4 gallons. We want to know what was this change. So 3.5 plus something gave us the 4.4. What is this middle number that was the difference from here to here? Well, the way we're going to solve this, now this is, honestly, this is just an equation. Watch. 3.5 plus, I don't care if you use C for the variable, equals 4.4. Now these have decimals in it, but we still can solve it. The opposite of adding 3.5 is subtracting 3.5 on both sides. These cancel out. C equals, now 4.4 minus 3.5. You can do it in your head, or you can go like this. So let's see, we've got a borrow. That's a 3. That's a 14. That's a 9.0. The change was 0.9 gallons. Okay, a couple things to make sure. First off, you have your label. And secondly, does your answer make sense? Is it possible to go from 3.5, you add almost 1 gallon, and up at 4.4? Yeah, that answer makes sense. Okay, always double check if your answer makes sense. Letter B. In a small garden, he has 12 rows of corn. In the whole garden, there are 96 stalks of corn. How many stalks of corn are in each row? Okay, so let's see here. Small garden, he has 12 rows of corn. I don't know who he is, but maybe there are 12 rows of corn in the garden. Okay. There are 96 stalks of corn altogether. How many corns are in each row? Each is a keyword. To me, that means multiply. So if you have something happening over and over and over and over and over and over and over again, that's usually a multiplication. So what we have here is we have these 12 rows of corn. So just imagine 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We don't know how much corn's in each row, but we know the total is 96 stalks of corn. So we can say, well, 12 times something. There's some number of stalks in each row, so maybe we'll call it an S, or C for corn. I like that. Equals 96. And we want to know how much corn is in each row. Well, the opposite of times by 12 is to divide by 12. Divide by 12. Cancel. C equals 96 divided by 12 is 8. stalks or 8 stalks of corn. Got your label. Let's check if your answer makes sense. So if there's 12 rows of corn and 8 stalks in each row, 8 plants in each row, is that going to give us about 96 plants total? Yeah, that answer makes sense. Letter C. Copy it down, read the problem, try it out. I'll give you a couple of seconds here. Pause the video if you need to. Try it on your own. Hit play when you're ready to go. When you're ready to continue. Okay, board was cut into 4 pieces. Each piece is 7 inches long. How long was the original board? Well, if you're cutting something, that's divide. If you're cutting a pizza up, if you're dividing something into different pieces, it's division. Okay, so we know here the board was cut into 4 pieces. So here's my board. I'm cutting it, dividing it into 4 pieces. And the result of that division, when I divided that thing, the answer, each piece, was 7 inches long. I want to know, how long was the original board? Well, let's just undo this math. So instead of dividing by 4, the opposite is to multiply by 4 on both sides. These cancel out. And I get the answer of my board was 28 inches long. Now let's see if that makes sense. Imagine you have a board. It's 28 inches. If you cut it into 4 pieces, dun, 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 how big is each piece going to be? We say it should be 7. Is that right? 7, 7, 7, 7. 7, 7 is 14, plus another 7 is 21, plus another 7 is 28. That is correct. We double checked our answer. We have our labels. We're good. Okay. Last couple practice problems before we're done here. Please try pages 136, 137, numbers 13 through 17. Right now, please. You can pause the video, and we will continue when you hit play. Okay. Number 13 says 5/6 W equals 10. Now, this is the fraction problem, so the way we're going to get rid of the fractions by multiplying by the reciprocal so that everything cancels out. So the 6's cancel, the 5 cancels, it's gone. W equals 60 over 5, which when we simplify, let's see, 5 goes into 60 12 times, I believe. 12, 24, 36, 48, 60. Yeah, 12. Number 14. 2/3 P equals 14. We're going to multiply by the reciprocal, so times by 3 over 2, times by 3 over 2. These cancel out. P equals, and let's see, 14 times 3 is 30, 42 over 2, which when we simplify gives us 21, and we're done. 15. 9 equals 3/4, negative 3/4 m. So we're going to multiply by negative 4/3. So the negatives cancel, the 3's cancel, the 4's cancel. It's kind of ugly. Basically, you get the m by itself on this side. On the other side, we multiply by negative 4/3. Let's see, we get 9 times 4 is a negative 36. 3 times 1 is 3. And if we simplify that, draw a line here. If we simplify that, we get a negative 12. Lastly, number 16 says negative 8 equals negative 4/5 V. Same thing, times by a negative 5/4. That's the reciprocal of that fraction. Times by negative 5/4. So this and this cancel. We get V equals, let's see, we get a positive 40 up top and a positive 4 down below. Simplifies, gives us 10. Pause the video if you need to see the work a bit more. I'm going to erase it to do number 17. 3, 2, 1. Clear ink. Alright, number 17. I'm reading for the book. It says, in example 6, suppose Sean Crawford ran 100 meters in the same average speed he ran the 200 meters. How long would it take him to run 100 meters? Round your answer to the nearest tenth of a second. So first off, we have this formula for speed, distance, time. It's called the distance formula. And it goes D equals RT, where D stands for distance, R stands for rate, T stands for time. And rate is like how fast you're going, your speed. Okay, so this dude is running the 100, I'm sorry, if he ran the 100 meters at the same speed he ran the 200 meters, so his distance, 100 meters. That's how far he's running. If he's running it at the same speed he ran the 200 meters. Well, let's look at the problem above. He ran the 200 meters in 10.1 meters per second. 10.1. And we want to know, how long would it take? What is his time? So there's our setup. Everything checks out. We're trying to find a time. We have a speed. We have a distance. So now we just solve this thing. So if I divide by 10.1, divide by 10.1, these cancel. T equals 100 divided by 10.1 gives us 9.9 seconds. Which, by the way, it's a pretty fast run. 100 meter dash, 9.9 seconds. Really good. Okay. Now, in the summary box at the bottom of your note sheet, you have one question. It says, how do you solve one-step equations? Give me a sentence, a small explanation. How do you solve these one-step equations? In every single problem, what did you do? Pause the video, write down an answer. If in your head you're thinking, I don't know, that means you really didn't understand the point of the lesson. You should have some idea of something to write down. So, here's what I'm thinking. How do you solve one-step equations? Well, you got a couple different things. First off, you always do the opposite of what's happening to the variable. To the variable. Okay? So you always do the opposite of what's happening to the variable. So that would be, if it's adding, you subtract. If it's multiply, you divide. You can say that. Always do the opposite of what's happening to the variable. And subtract are opposites. Period. Multiply and divide are opposites. Your goal, the final goal of every single equation you're ever going to solve, I don't care how many steps it has, if it says solve this equation, your goal is to get the variable by itself. Get the variable by itself. And if you double check any of the equations we solved, the very last step, the thing that I circled, every single question, it either has like m equals something, b equals something. There are no negatives next to the variable. There are no fractions next to the variable. There are no decimals next to the variable. It's the variable c equals. The variable c equals. K equals. X equals. Now here, because I was simplifying, x equals negative 14. Y equals 3/5. M equals negative 8. Every single problem, the variable is by itself. That is the goal when you're solving an equation. Okay? And the thing you've been waiting for, that is your homework. pages 137 through 139, 3 through 42 multiples of 3. So for those who don't know, that's like 3, 6, 9, 12, 15, 18, dot, dot, dot. Skip 2 questions between each. So you skip, there's 3, you skip 4 and 5, 6, skip 7 and 8, 9, skip 10 and 11. And then these other couples. Alright? So this has been lesson 3.1. I hope you enjoyed.